Welcome. Today, we are jumping right into some really important stuff, the mandatory electrical tests. You know, the ones every single installation has to pass according to the AS/NZS 3000 wiring rules. Stick with me for just a few minutes, and I promise you'll have a solid grip on all the mandatory live and dead electrical tests. We're going to cover what they are, when you do them, and most importantly, why they are so critical. So here's the game plan. First, we'll break down the two main types of testing. Then, we'll get into the details of both dead and live tests. After that, we'll see how this all plays out in the real world and wrap up with a quick safety recap. Ready? Let's do this. All right, first things first. We've got to understand the core idea here, the difference between dead and live testing. Seriously, if you get this, everything else will just click into place. Dead testing? Well, the name kind of gives it away, right? The power is completely off. This is what you do first on any new or modified job. The whole point is to hunt down any big problems with the wiring. We're talking damaged cables, wrong connections, before you even think about flipping that switch. It's really the bedrock of safety. Then you've got live testing. And yep, you guessed it, this is done with the power on. This only happens after you've done all your dead tests and you're confident the basic wiring is sound. Live tests are all about making sure the safety gear, your circuit breakers, your RCDs, or residual current devices, are actually going to work when it counts. Here's a super simple way to picture it. Think about plumbing. Dead testing is like checking all your pipe connections for leaks before you turn the water on. And live testing, that's when you crank the tap open to check the water pressure and make sure all the safety valves are working. Makes sense, right? Okay, let's dive into the details. We'll start with the mandatory dead tests. These are the checks you absolutely cannot skip. They're all about making sure the physical installation is solid. So there are 4 key tests you got to do here. You've got the insulation resistance test, the continuity test, the polarity and phase rotation test, and the earth continuity test. Each one looks at a totally different but equally vital part of the system. Now, the insulation resistance test. This one's a big deal. It's all about checking the health of the insulation wrapped around the wires. Basically, you're making sure electricity stays where it's supposed to and doesn't leak out between the active, neutral, and earth. If this test fails, you could be looking at a short circuit or even a fire as soon as you power up. Not good. And here's the magic number, the pass or fail mark. The standard demands at least 1 mega-ohm of resistance. So why so high? Well, anything lower than that is a huge red flag. It means current might be leaking out somewhere, maybe from a damaged cable. It's a crystal clear benchmark for safety. All right, next up, we have continuity and polarity. Continuity just checks for a complete unbroken circuit. Simple. But polarity, this one is critical. It makes sure the active, neutral, and earth wires are plugged into the right spots. You get this wrong, and you could accidentally make the metal case of an appliance live. That's incredibly dangerous. Okay, let's talk about another critical number, this time for your protective earthing. The main earth wire needs to have a resistance of less than 1 ohm. Why is that so important? Think about it. During a fault, electricity is lazy. It always takes the easiest path. Keeping that resistance super low guarantees the easy path is straight to the ground. That's what lets your safety devices see the fault and trip in a heartbeat. Okay, power is about to go on. Now it's time for the live tests. We've confirmed the wiring is physically correct and safe to energize. So now we have to see how it all actually behaves under load. There are 3 main live tests we need to tackle. First, voltage and phase sequence. Second, the RCD trip test. And third, functional testing. These are all about confirming the power supply is right and, crucially, that those life-saving safety devices are ready to do their job. The RCD trip test is probably one of the most important life-saving checks you can do. RCDs are designed to spot tiny leaks of current, the kind that could flow through a person and just snap, cut the power instantly. This test creates a tiny controlled fault, usually around 30 milliamps, just to make sure that RCD trips in time, typically within 300 milliseconds. This test is literally what stands between you and a nasty electric shock. And it's super important to remember, you can't just wing this with any old gear. Each of these tests needs specific, properly calibrated equipment. We're talking everything from a basic multimeter to a specialized RCD tester. Using the right tool isn't just about best practice, it's about getting results you can actually trust. So that's the theory down, but what does this look like out in the real world, on an actual job site? Let's bridge that gap. Just think about it for a second. That electrician putting in a new public light pole, they have to do an earth continuity test. That huge new switchboard going into a commercial building, it needs a full insulation resistance test before anyone dares to power it up. Even a simple job like adding a new power point in a house means you have to test the RCDs. This stuff is happening all day, every day, on every single job. This really brings it all together, doesn't it? Dead testing, it's all about checking the integrity of the build. You do it before you energize, and the risk is pretty low. Live testing, that's about operational safety. You do it after you energize, and the risk is way higher. That's why you need strict procedures and all your PPE. And look, you've got to remember, this isn't just about flipping some switches and calling it a day. It is a formal process. Every single result has to be written down on a certificate of compliance. For live tests, you need the right PPE, no excuses. And your gear has to be calibrated. When it comes to safety, there are zero shortcuts, period. Okay, we've gone through a ton of information. So let's wrap this up and really lock in the most important points with a final recap. When you boil it all down, it's a simple two-step dance. Step 1, power off. You run your dead tests, insulation, continuity, polarity to check the physical wiring. Step 2, power on. You do your live tests to prove everything works safely, RCD trip, voltage, and all the functions. So if there's one thing you take away from all this, let it be this. Dead tests find the mistakes made during the installation. Live tests prove the safety devices actually work. And those numbers we talked about, the 1 megaohm, the 1 ohm, those aren't suggestions, they're hard and fast rules. At the end of the day, following the correct procedure to ensure safety is what this is all about. And that's the bottom line, really. Live and dead testing, they aren't optional extras. They are the absolute mandatory foundation for making sure every single electrical installation is safe, compliant, and built to last.